Section 3.1 Measure of center. This section represents measure of a center, including mean, median, mode, and mid-range. Some people refer to the mean as an average. In fact, there are many kinds of average. The mean is just one of them. Okay, now let's look at the formula. The mean is equal to sum of the data values divided by the number of data values. If your data are a sample from a population, then the mean is called sample mean. And sample mean is denoted by the x bar here. Sample mean is equal to summation of x divided by the n here. Summation means sum of a set of data values. And this n here represent the number of the data values in a sample, okay, in a sample. And if your data from a population, then the mean is called population mean. And population mean is denoted by the mu here. Population mean is equal to the summation of x divided by the capital letter N. And this N represent the data values in a population. Okay, so I have this formula here. Okay, let's try this example. Find the sample mean of the following test series. Okay, I want you guys try to do it. Okay, let's check the work. You need to apply the sample mean formula. Summation of the x means you add up all the data here and then divided by 5 because we have 1, 2, 3, 4, 5. We have 5 data here. You should get the sample mean equal to 85.4. Okay, median. Median is the middle values in the data set. So finding the median, here is the step to find the median. Arrange the data values in increasing order. Determine number of the data values n. And there's a two step. If n equal to odd number, median is the number in the position of n plus 1 over 2. If n is an even number, then median is the average of the middle two numbers. And these are the number in the position n over 2 and n over 2 plus 1. Okay, let's try to do the example together. Find the median of the exam score. So first step, we need to arrange the data values in an increasing order. Okay, so we're going to rewrite this one in an increasing order. Then we need to determine the number of the data values n. So we're going to count 1, 2, 3, 4, 5. So your n is going to be equal to 5 here. And 5 is an odd number. So the median is the number in the position of n plus 1 over 2. Okay, this is a position of n plus 1 over 2. And your n is equal to 5. So you plug in here n plus 1 divided by 2, which is going to be equal to 3. Okay, now let's look at the data here. 1, 2, 3. So we have a 78. And the median is 78. Okay, now let's try the other example. Find the median of this list of the data. So first, we have to arrange the data values in an increasing order. Okay, we write it in increasing order. Now we need to count what is my n here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so n equal to 8. And this 8 is an even number. So the median is the average number of the position n over 2 and n over 2 plus 1. Okay, so we're going to plug in n equal to 8 here. Okay, we need to look for the position of x over 2 and x over 2 plus 1, which is equal to 4 and 5. So we're gonna count 1, 2, 3, 4, 5. Okay, so that will be your 15 and 19. We do have the two numbers here. So median is the average of these two numbers. So find the average. We're gonna add it up and divide it by 2. So that will be equal to 17. And the median is equal to 17. Okay, remember median is the middle values in the data set. Actually, when I look at the data here, you could cover up the first two numbers here, cover up the last two numbers here. So 78, that would be the middle value here. So this is going to be my median. Same idea for the example 2. I could cover up the first three numbers here, cover up the last three numbers here. So you can see there's two numbers in the middle. So we're going to find the average of these two numbers, which is 17, and that will be my median. Okay, mole. Mole is the value that occurs most often. And a data set can have a 1 mole, more than 1 mole, or no mole. If there are 2 mole in the data set, we call bimodal here. For example, 18 and 21 appears 2 times in the data set. So 18 and 21 are the mole, and we call this as bimodal. And multimodal, more than 2 data values occurs with the same greatest frequency. So look at this example. We have a 2, 8, 2, 12, and 2, 21. So 8, 12, and 21 are the moles, and we call this as multimodal because more than 2 data. And then no mole means no data is repeated. Like this example, all the data value occur only once. So there are no mole here. Okay, last one, the mid-range. Mid-range is equal to the maximum data values plus the minimum data value and divided by 2. Okay, but mid-range is rarely used. So for like this example, the maximum data value will be 28 and the minimum data value will be 5, right? So we could add it up and then divide it by 2. So when you add it up, that will be 33 divided by 2, which is 16.5. That will be the mid-range. Okay? Okay, calculating the mean from a frequency distribution. Here is an example of number of text messages sent by the high school students. So look at here, frequency 10 means we do have 10 students send a text message between 0 to 49. And then we have 5 students send text message between 50 to 99. So first, we need to find the midpoints for each class here. Okay, remember how to find the midpoint? We would use the 0 plus 49 added up, divided by 2, that will be your midpoint. Okay, and we got 24.5 here. After you find the midpoint, you're going to use the midpoint times the frequency. Okay, so 24.5 times 10, that will be equal to 245. Okay? So can you complete this table first? And make sure you find the total of these two columns. Okay, let's check the work. Okay, when you added up the sum of the frequency, that will be equal to 50. Okay, again, this is summation notation, means you added all up for the frequency, that will be equal to 50. And the midpoint, added up divided by 2 for each class. You should get these numbers. And midpoint times frequency. Okay, and then you add it all up. We call this a summation of frequency times the midpoint. You should get 6,825. Okay, we want to find the mean from a frequency distribution. So the formula is going to be like this. Mean equal to summation of frequency times the midpoint divided by summation of frequency. Okay, so we're going to plug in these two numbers here, which is equal to 136.5. Okay, so far we learned how to find the mean, the median, the mode, and also the mid-range. And we also know how to find the mean from a frequency distribution. Okay, actually we could use the calculator to take care of those calculations. Before we go through how to use the calculator, let me talk about the last part here. Okay, skewness and the mean, median, and the mode. Okay, after we figure out the mean, median, and the mode, we will have an idea about how the data look like. For example, if you find out the mode is greater than the median, is greater than the mean, then the data is going to be skewed to the left. Okay, skewed to the left. Remember, we say skewed to the left means the left tail is longer. Okay, and if you find the mean is greater than median, greater than the mode, then the data is going to be skewed to the right. Okay, so means like the white tail is longer. And then the last one, when the mean equal to the median equal to the mode, then we will have the normally distributed data. Okay, the normal distribution. Okay, now let's go back to learn how to use the calculator to find the mean and the median. Okay, that's my calculator. First, I'm gonna click on the stat. Okay, the stat here. And then I'm gonna go to number 1 for edit. You can see that's a L1, L2, and L3. And then I'm gonna enter my data into the list editor. Okay, for example, this is my example. I'm gonna input the data here. So I have 20, 15, 12, 27, 13, 19, 14, and 21. Okay, after I input the data, I can go to the stat. You could see the cal here. So I'm gonna use my arrow, go to the cal. And I'm gonna choose number 1 for one variable statistic. And then my data list is gonna be on the L1, okay? So I'm gonna press second, and then 1, which is my L1, and then enter. Okay, you can see the first one. This is gonna be my mean, 17.625. And if I want to find the median, I will use the arrow to go down. Okay, you can see the MED, which is my median. That would be equal to 17. Okay. Okay, second one. We could use the calculator to find the mean and the median from a frequency distribution. Okay, so now let me clear everything here. I'm gonna go to the stat again, go to number 1. Okay, you can see I already have a data in L1. I could clear it. I can use my arrow, go up, and then highlight the L1. Then I'm gonna press clear and then enter. So all the data is gonna be disappear here. Okay, now I will input the midpoint values into L1 and the frequency onto L2. Okay, I'm gonna reuse the example here. Okay, midpoint, that will be my L1. So 24.5. 74.5. Okay, and then I'm gonna use my arrow, go to the L2, and then I'm gonna input the frequency, okay? Frequency, not the midpoint times frequency, only frequency. 10, 5, 13, 11, 7, 4. Okay, one more time. The midpoint, that will be on your L1. The frequency, that will be on your L2. Okay, after I put the data here, I'm gonna go press the stat and then go to the cal, and I'm gonna choose the first one variable statistic, and then I will press the second one, okay, and then comma, okay, make sure you put the comma, and then second 2. This means my midpoint is gonna be the data L1, the frequency that will be on the L2 here, and then enter. Okay, you should find the mean here, that'll be 136.5. Okay, this is what we found it from the example here, 136.5. You also can see the median here also, 124.5. Okay, last part, we need to know which measure of a center should I use. First one, we're gonna talk about the mean. Advantage. Sample means drawn from the same population tend to vary less than other measure of centers. Means they take every data value into account. Remember how to find the sample mean, right? We're gonna add up all the data together and divide the number of the data. So the mean is the most common measure of a center. However, the disadvantage is sensitive to every data value. One extreme value can affect it dramatically. So look at this dot plot. I have a dot plot in here. You could see all the data that will be within from 65 to 85 here. But I only have a one data that's fall into the 10. So we believe this data will be our outlier. Okay, this is the outlier. If I want to calculate the sample means using this data, we're gonna add like from the 10, 65, 65, 65 until added up to 85 and then divided by the number of the data. But because of this outlier, it will be affect our sample means. So because of this data, our sample mean may be falling from some 60 or something in here. If without this outlier, I only calculate the sample mean using this part of the data, you're gonna find it out the sample mean will be 70 of something. So we say this is a sensitive to the outlier. It will be affect our sample mean dramatically. So it may not be the best measure of a center when you have outliers. And then second one, the median. It is resistant measure of a center. Resistant measure are not affected by an extreme value. So you could see this means less affected by the outliers and the school data. So think about it. Look at the dot plot again. So if I want to find the measure of center, this time I'll be finding the median. Remember how to find the median, right? We're gonna short the data and then we're gonna find the middle one. So you could think about it. I have a 110 here. I take out this one, take out this one, take out 65, take out 65. We may find it out the measure of the center is going to be 70, 70 or 75 or something in here. Okay, and the median is less affected by the outliers. So if you have the outliers and you want to calculate the measure of center, median will be the best choice. And also the school data. Remember, if you have the data skewed to the left or skewed to the right, and you want to find the measure of the center, median will be the best measure of a center. But if you have the normal distribution, remember what is the normal distribution, right? The frequency start low, goes up, and then Go back to low again, it's about symmetric. When you have the normal distribution and you want to find the measure of the center, the mean will be the best measure of the center. And then the last one is the mode. Mode is used for the categorical data when we wish to know which is the most common category. So for example, if you have a data set about like the favorite ice cream, okay, you may have a chocolate, strawberry, vanilla, chocolate mint. So this is a category data, right? So if you want to find the measure of the center, mole will be the best choice in here.